If you're going to be standing there, that's fine. All right. Thanks, everybody, for coming. Before we begin, can you guys please tweet at SF CloudOps, post some pictures, hashtag, hashtag, hashtag. Docker, AWS Cloud. We want to spread the word. This is our 5th meetup. Great turnout. This is a new space for us. We had a much smaller space last time, but now we can accommodate, I think, up to 150 people. 150 people are RSVP'd, and I think there's about 80 to 100 here now. Our meetup has been growing every time, so started from 30, and now we're up to 400 members. There's a lot of, every time we try to book some interesting talks, and this time we got Avi from Shippable.io talking about Docker and how they're using Docker in AWS to optimize for costs and gain 2x scale. So we're also going to talk a little bit about Skybase, which is a project at Lithium here. It's a project to create a DevOps as a service framework to be able to deploy code into various cloud environments as well as manage it after it's deployed. And then we have a prize raffle. There's a Chromecast, and you guys should have gotten a raffle ticket when you got in. Everybody has a raffle ticket? Awesome. So let's get started. Before we get started, a round of applause for Tara, who is mixing drinks for us there. Awesome. So without further ado, Avi. Where are you, Avi? Oh, there he is. Give a warm welcome to Avi.
Cool. Thank you.
There you go. You need power?
It's okay. Ooh. That one is okay, right? Or no? Is it my resolution? Maybe I'll turn off. Wow. Anybody has any idea how to fix this? It looked right?
Yeah, it looked right.
Really? I thought it was all. Okay, that's fine. Cool. Sorry about that. My name is Avi Cavale. I'm the co-founder and CEO of Shippable. And this talk was called Gaming AWS with Docker before. I thought we need to have a little bit more positivity, so I changed it to Optimizing AWS with Docker. So thank you very much for Lithium for inviting us over here, and I'm super thrilled to be presenting here. So what Shippable is basically a continuous delivery platform, and we use Docker as the underlying technology, and we basically started out as continuous integration. And as we started evolving, we realized that containers are going to be here for the future. So we started saying, hey, we are building all this stuff with containers, so we should surface this out for all our customers. So basically, that's what we do. There are a couple more slides about what we do towards the end, but pretty much everything else is about how do we use Docker and how do we use AWS. So the question to start with is, why is AWS so successful? And there are a lot of answers. There are a lot of things that people talk about. But what I really think is a little bit controversial. It's because of what they don't let you do. Everybody thinks that it's because of what they let you do. And I kind of believe that it's because what they don't let you do, and it makes it much more scalable for them. And kind of talk about it, people really start questioning, I mean, is this really a true fact? And recently, they also start thinking that this is what's happening, and that's why I'm talking like this. But really, what I'm talking about is corporate data centers is what the main problem was. So what happens in a corporate data center is there's no standardization. It's everything that everybody wants. I can ask for anything, even to the point where my router switches can be configured the way each application wants. So what ends up happening is you create a completely heterogeneous platform. And the reason for all of this is every single app thinks they're unique. And they want something completely different. And for somehow, all these apps somehow run on AWS when you don't have all these customizations. So what ends up happening is app guys start fighting, and eventually infrastructure guys say, OK, we'll deploy 2 versions of this, and everything works. And you'll start seeing different topologies that are running on the infrastructure. And then the most important thing is the app doesn't deal with any kind of resiliency. I mean, there are some apps that are written this way, but majority of the apps are not written this way. They push everything to the infrastructure. So they kind of go and say, hey, I mean, we need clustering, we need RAID, we need this, we need replication, we need all kinds of stuff. And so your infrastructure starts becoming very, very complicated. Like I used to work at Xbox before this, Xbox Live, and Kinect actually. We had like a $30 million hardware budget, and that was what my team was spending. And our disaster recovery was close to maybe 7 days, if at best, even if I was spending $30 million of infrastructure. And it was just basically because it just was not replicatable across data centers. We could never, ever make it work because things were changing so fast. So we were always in manual process at some point. But on Amazon, this is what happens. They basically took this custom away from the customer. So they said, look, we're going to do this. This is how our platform is going to work. And you guys all have to deal with it. And you figure out how to make this resilient, and you figure out all that stuff. We are going to just do it this way. It is so crazy that you cannot even get storage that is persistent if you don't use EBS blocks. So everything that's attached to the machine is ephemeral, and you can pretty much lose it. Most of the times you get it back. They start getting homogeneous hosts. So these are massive machines. They try to buy very templatized machines. And they're usually multi-proc, multi-NIC, so that they can do virtualization on top of it. And then their whole business model is arbitrage. And everybody understand what arbitrage is? Just quick thing, arbitrage is basically you don't know what the actual price of the supply is, and you can sell it to whatever you want, and the difference is where you make the money. Like futures and all stock trades are all arbitrage, and that's how they think about future trading. So that's what they do. So what that means is your data center looks something like this. It's just templates of servers that are all physical machines. And then what they do is they sell stuff like this, which are all VMs that you're saying the whole M3 CX or C3 2X large, all of these things are different blocks of VMs that are getting placed on top of these physical machines. So that's where you see whole noisy neighbor issues and all of that, because it depends on what machine you actually bought and where you actually got placed and what was happening on that particular machine. So this is kind of how Amazon set up their whole infrastructure. So And the reason why I'm talking all about this is because Shippable was about making software engineering become more efficient. And so these were some of the facts that we were seeing with our own development. One was bug fixes took way longer than what it actually was estimated. And most of the times it's because it is not reproable. So what you end up doing is you start building more environments, trying to repro it. You have test 1, test 2, test 3, all this stuff going on. And that's where one of the first problem was. So the second problem was, because it's not reproable, majority of my engineering team was actually spending time trying to figure out how to fix these things, because it's a bug, it happened somewhere, so we need to go fix it, and somehow we need to figure out how to replicate it. And the result of this is there are actually over 100 million servers out there, and less than 30–40% of them are actually production servers. Majority of them are dev and test servers, because it's easy to spin up these things. They might not be as beefy and big, but the numbers are pretty much out there. So almost 2/3 of servers are all dev and test or some kind of pre-prod environment. So basically all of this leads to this, which is what we were trying to solve, which is every time any bug occurred, the first thing my devs told me was it worked on my machine. And I don't know why it's not working out there. And the reason why that happens is you're trying to do single box testing. And you're trying to do everything in isolation. You're trying to build stubs out. And what that means is it works at one point, but when you start bringing things together, you start finding issues which weren't there before. It could be network. It could be a whole bunch of stuff. So what ends up happening is on integrations phase, the cost of fixing them is significantly higher, because most devs, including myself, I mean, I don't remember code if they show me something that I wrote 2 weeks ago and ask me to read it and tell me exactly what happens. It takes me a while to figure that out, what I was actually trying to do. So it's just not the price of fixing the bug, it's just the time taken to fix that bug. So that's where the problem starts. And what we were about was about speed. And we wanted things to be faster. We wanted to ship 10 times, 15 times, maybe even 50 times a day into production. And all of this was not possible with the whole VM technology and how we were trying to do. So first thing what we did is we said, okay, we're going to do agile dev with distributed CI. So what that basically means is every single dev is doing CI locally before actually pushing to a central system. So that's the model. So the way it works is you have a master, and MW is middleware in this case. It's one of the components. So you do a fork, and you have your own version of master, and then you start coding on it. The fork actually is hooked up into a CI environment, and then you're running on top of that. So CI is running continuously, and every time you say, okay, I'm ready to push, I push it back with a pull request to my master. Another CI gets triggered, and this time it's comparing against masters with the merge without actually having merged it. And then if this all succeeds, then it gets pushed to pre-prod, which eventually goes to production. So this is like a very, very simple workflow of how development actually happens. And usually 2 developers are working on a single component, so it ends up looking like this. So what that means is I have a 1 box for CI here, I have a 1 box for CI here, and these 2 CIs are exactly the same. So it's actually 3 boxes to actually make this work. Now I could pretty much say I'm going to spin up VMs, I'm going to write all automation to do all of this stuff, but it's still a VM, and it's expensive to keep running all this infrastructure. And even if I do all of this, it is still single box. I've still not solved my topology problem, which I'm going to get there. So to kind of put a costing on this, it looks something like this. So 3 VMs per component, $50, M1 medium. Anybody has tried using anything smaller than that? I don't think it runs at all. So I think this is the least that we could go to. And we had about 8 components, like caching, middleware, UI, all kinds of stuff. So it gets to somewhere about $1,200 a month. And especially for a startup, which we didn't have, we had not raised money, it was bootstrapped, this was super expensive. And this is just to do builds. We were not even talking about production or anything if we really wanted to get the speed that we were really trying to get to. So if you look at TCO, it looked something like this. So we were spending about $4,000 just to run our infrastructure, and we had hardly 50 or 60 customers at that point of time. And this was all engineering dev that we were spending a lot of money on. So what was happening was, I think we said, okay, this is not scalable because we're not doing topology. If I do topology at individual developer, now multiply this cost by another 8. And so we started getting into this mode of like saying, this is really not working out for us. So either we go back to daily builds or weekly builds or nightly builds or something like that, where again you're getting into triage model and all of that problem, or we have to figure out how to solve this. So the lucky thing was Docker happened last August. So I think it was around July, June timeframe where they open sourced it. We started experimenting with containers to try to see if we can solve this problem. And Docker came out and we said, okay, fine, let's not spend any resources trying to solve this problem. We don't know whether the world is going to use Docker or not, but it solves our problem. And that's how it started. And we were kind of trying to solve the CI, but we started seeing containers as the future. So the way this works is you pick a zone on Amazon, try to find an isolated zone. Usually don't try to pick something that has a lot of traffic so that there's not too many people there. Then what you do is you provision the biggest possible machine on top of that. So now what you have done is you are the bully on that machine, and everybody else is going to look at you as the noisy neighbor, and you don't care about what the hell they are doing, right? So then what you do is you layer Docker on top of it. And this is something that was fascinating to me, that I could actually do this on a VM. And that was the beauty of what Docker was trying to do. And then what you can do is then you can layer a fabric on top of it, which kind of gives you these micro machines. And people think that the performance of this is bad. It's actually not, because of one single thing, which is the OS is not inside these containers. So the OS is below it. So technically, if you have that many VMs, you're just losing maybe a gig, maybe 1.5 gigs, depending on what OS you're using. And it's all just gone because of running the VM itself. Whereas here, I could actually put that onto the host and then run very lightweight containers on top of it. And in our world, it was pretty homogeneous, and we could actually run this. Is everybody with me so far? Cool. So, and then what ends up happening is our production started looking something like this. So instead of having all those VMs, which were all medium, we started breaking it down into two big machines. This is for redundancy. If one goes down, we still have things available and all that stuff. You could potentially run it on a single machine if you really want to. But this was how production ran. And all our dev has single machines, because we don't care if the machines go down. So the costing was this before. And with the new stuff that we got, it started looking something like this. And the advantage of this is at $300, I could run 60 containers, 80 containers on those machines. And honestly, today, on a C3 X4 large, we run 2,000 containers. And we have no issues, because we are running builds and tests and all that stuff. It's transient workloads, so you can actually run it independently. And we have some algorithms that figures out how to actually balance this out. But technically, you can run 2,000 containers running on that system. So what that did is, for that price, now I can get full topology testing. That is 8 components for every single developer. So we have 15 developers. So I have 120 containers running on 2 different machines, and they all have fully dedicated environments. So if somebody comes and says, it works on my machine, the first question I ask is, did it work on the topology? Because if it didn't, then it won't work in my pre-prod environment also. So we are trying to push all the stuff closer to the developer and making the onus be on the developer's shoulder than trying to bring it all into one single place and trying to get it later down the lane. So that's basically what we're trying to do. And then, even though the costing was this, we still got all this stuff. And this is where the magic started happening for us, where we started looking at containers as immutable things that can be moved around. So technically, I can test everything as early and just ship containers through the stages, as opposed to rebuilding everything on every single stage. And so think of it as, if you look at what DevOps was, it was about recreating something programmatically in one environment that actually existed in the other environment. Right? That's what DevOps was all about. How do I repeatedly, programmatically do this again and again and again, and not have to manually do this? And if you go and look at most of the guys, the best release that I did, at least for Shippable, was the 1.0, where it was all beta. And one day we just said, this is going to be production. And we just changed the Route 53 routing, and it became www.shippable.com as opposed to beta.shippable.com. Because if you can kind of get to that kind of DevOpsy world, then suddenly a lot of inefficiencies are gone in your process. And that's what we started seeing as a potential of what we could actually do. And it also gave us instant spin-up. So even if you have fully AMI'd environments, it will take you anywhere between 8 to 10 minutes to bring up an environment. Even like a simple 3 or 4 box environment, it will take you anywhere between 8 to 10 minutes. And the problem with AMIs was that if you patch it, you have to redo the whole AMI. And anybody who has tried to do saving of snapshots onto AWS and trying to restore it in another availability zone probably understands how difficult it actually is. So we got all of that for free. We could actually spin up environments in less than 5 seconds. So our entire infrastructure for shippable production, which runs about 6,000 plus customers today, we can go from 0 to fully deployed in about 4 minutes. And this includes deploying the VMs and all of that stuff. I mean, of course, data is not part of it, but I can bring up a brand new system across the board. So if I had just replicated my data into another database, into a different data center, my disaster recovery is actually 4 minutes. And with $30 million of budget at Microsoft, we could still not get it below 7 days. Maybe it was bad engineering, maybe it was bad data centers, but whatever it is, it was still 7 days. So we started getting additional benefits like that. So to kind of summarize it, what we got was a 70% reduction in TCO. And so from 4,000, we went to 1,200. And most of these numbers are 2013 numbers. And we thought this is going to go up, but interestingly, it's remained the same because we have really not seen, Docker has gotten better, our processes have gotten better, so we are running more and more number of customers on the same exact platform. And beyond that, it also was, everybody talks about money, but the main problem was management of 54 machines that was additional. So I don't need to patch them, I don't need to worry about anything, I don't need to worry about whether these machines are up and running. So things started becoming much simpler because I had lesser number of machines to actually manage, and everything else was on top of it, which was kind of like a container layer. So think of it as 60 to 6 VMs is where we got to. But at this point, I mean, this was the presentation that I did at Gluecon. One of the things that happened is we started talking about this, and we realized everybody started coming and asking, this is all great, but do we need to do all of this stuff to build this? And that's where I think I kind of want to go back to Shippable, and what we are doing in 2 weeks now is basically we're launching 2.0, which is basically whatever I talked about as a service. So you can basically say, hey, you bring me your VM, and you just hook it into our service, and you suddenly can containerize your entire infrastructure. So think of it as instant labs, instant dev labs, whatever you want to talk about it actually in the cloud. So the left part, the green part, is what is 1.0, where we do, like you see the minion hosts, which is on that big block there. That's the Docker fabric that we have. And what we are doing is something like this, where we are allowing people to bring hosts from wherever they're actually bringing in. So now what you're trying to see is almost like a fabric that's going across cloud providers. So now you can actually think about, I can have my dev machines running on AWS today, and just because of whatever reason Rackspace decides to give you 50% discount, you can migrate there within 4 minutes, and you're pretty much done. And your whole dev labs, everything runs exactly the same way as it was. And it's not just that, you could actually bring this on your own premise too. You could be running a VMware stack or a KVM stack or a Xen stack, whatever you're running on your own machine. So you can actually start doing hybrid clouds without actually breaking your head too much. And you can even get into cloud bursting scenarios from your dev perspective if you want to get to. And I'm saying dev again and again and again just because that's our focus, and that's where we are really trying to drive towards. It's all about how do I get things going faster. So basically beyond that, what we are doing is topology testing, which is what I was talking about. We're also doing enterprise GitHub. And one other thing that happened was we just signed a partnership with Google, where if people have heard about Kubernetes. So yeah, it's just an API that actually abstracts all the clouds for you. So you technically can push to one single API, and you can potentially push to any cloud you want to actually push to. So we are doing that integration where the decision to ship is all shippable, and then the act of shipping is the Kubernetes API, which actually will push it. So, and then of course we are doing on-premise. So my big call to action is just try it out, give us feedback. And the reason I say this is over 73% of all the features that we put into V2 were actually customer feedback. We didn't think about on-premise scenarios. We didn't think about bring your own host. Customers actually told this is what we really want. So try it out, give us feedback, and it's free. So you can actually try it. It's absolutely free to use even for private repositories if you want to do it. So that being said, Shippable, what it is shipping lanes for your containers. And it's www.shippable.com. And again, my name is Avi Cavale. You can reach me at avi@shippable.com or tweet to me at avinci. I'm pretty regular about replying to this. So thank you very much for Lithium hosting us, and appreciate all of you guys showing up here on a Tuesday evening. It's a long day, so thank you. Yeah, I mean, any questions, I'll be more than happy to. So the question was how to deal with networking with Docker containers. One of the advantages of doing in dev and test is it's running on a single box, so you can kind of get around it. But for our production service, we actually have a discovery service which tells us where different containers are actually running and what their ports and IP addresses are so that we can talk to it. No, we run our own Redis server. We use our own Redis where we are storing all of that. The plan is to move to CoreOS, which actually has all of that automatically in there. And you can actually run CoreOS on AWS, but the real value is if you run it on bare metal, because now you're actually taking out that whole virtualization layer, replacing it with a 35 megabyte layer, which is dealing with Docker and all the discovery and all that stuff. And also Kubernetes also allows you, if you want to kind of push it out, they deal with all that networking stack if you want to really do it that way. So again, this is still very early stage of the product. We are going to keep iterating on it. So.
Yeah, so how are you automating the deployments of the containers? Are you writing to the Docker API, or are you just making odd templates in Kubernetes and pushing to the Kubernetes API?
So the question was, how do we automate our deployment? Do we use Docker APIs or do we use Kubernetes? We don't use Kubernetes yet. We just kind of got into the partnership just 3 days ago, so it's very, very early. And Kubernetes has been there only for like a month, I think, right now. So we do use Docker APIs if we want to kind of push it outside of our domain, but we run our own hub also. So we actually, it's network latency. I mean, if you've tried pushing to Docker API right now, it's pretty slow. I think there are tons and tons of people trying to push it. So we use a hub ourselves. We run our own Docker index, and we push everything there. And as a backup, we lazily push to Docker whenever we want to push to. But it is all versioned. So every container is actually versioned by the GitHub chain set. So what you can do now is technically say, hey, deploy me the container that was 2 years ago, and I can just deploy it exactly as it was because it's fully immutable. I mean, even if you have any kind of automation or everything, it's still not immutable because your dependencies might not be immutable. So you might say, I want to install something. Somewhere somebody could have used a star in their package.json or something, and they will change the version. Whereas in this one, it'll always be the exact same one. So we use that, and we have a topology layer on top of it, which tells us what is an application, which is basically chain set IDs of all the different repos, and that goes as a blob, as a whole pod, which is exactly into Kubernetes API. Anything else?
So a question about Docker. How doesn't the noisy neighbor problem extend to like containers where you might have, it might be your own component, but if some container is misbehaving, it'll interfere with other containers on that same VM?
Absolutely. I mean, you have exactly the same problem. The advantage you have is you have a lot more control in trying to move them out much faster than if you have a VM. Like you can do live motion and stuff like that, but it really doesn't work that cleanly as Docker containers actually do. Because the main reason is your VM itself is like 1.5 gigs or something, and you're trying to move it across the wire. Whereas here, your Docker container could be 120 megs, and moving that across the wire is much, much faster, as long as you have the base images on both the machines intact. Got a question?
How much disk space do you provision for a server with 2,000 containers?
How much disk space do we provision? I think right now we are running, I think 2 terabytes per host, if I'm not mistaken. And most of that is for versioning. It's not really because we are actually, I mean, we keep all the versions and all that stuff because it's just for performance reasons. But you can potentially start kind of having a moving window where you can start dropping off old versions. You can say, hey, 3-month-old version will take you an extra 10 minutes to pull. And so you can kind of get away with it. But right now we're about 2 terabytes right now. And most of our containers are about anywhere between 100 to 125 megs. So.
How do you manage the complexity of having all those containers?
So I mean, that's all part of the cloud fabric that we have built. So the question was, how do we manage the complexity of all these containers running and the state of all these containers? So, excuse me. So we have 2-3 things. One is we know exactly the state of each container that's stored into MongoDB, and we are using that on an ongoing basis. The second thing is we have a pulse that runs inside the container, which actually is beating to a central service. And that's how we know actually that, hey, containers are all alive and running. And the cool thing about Docker container is even if the pulse goes down, you can bring back that containers in like less than 5 seconds. So and the pulse can be pretty lazy also. You don't really, and we do exponential backouts on the pulse so that we can actually don't have to keep on pinging it. Somebody else have a question? Yes. So the question was, if the container goes down, do we bring it back up? Yes. So we manage all of that state and all that stuff.
Can you set like a replication factor, like say I want 3 of these containers, I guess Kubernetes does that.
Exactly. So the question was, can we have counts and all that stuff? Yes, I mean, that's part of the pod, which somebody here was talking about, which is you're basically saying your application is a combination of containers and a count of these containers in terms of how many do you want. And Kubernetes is Kubernetes is very focused on production. And they're talking about how do I take this app into production. Where we are focused on is all about dev and test. So for us, we are a lot more resilient to, hey, if it goes down for 10 seconds, it's okay. We don't need to be that aggressive. And the other thing also is, since it's all webhook-based triggers, we know that you're trying to build before actually the build needs to run. So we get like another 2-3 seconds there where we can actually bring up the container if we choose to. But Kubernetes has all that built in where they call it imperative state, which is they're trying to get to a particular state. This is my desired state, this is my current state. Am I at my desired state or current state? And they keep trying to get to that. And so if you scale down, they'll automatically scale down. And if you scale up, over a period of time, they'll automatically scale up. So, somebody had?
Is Shippable interested in doing similar things with OpenStack as they do with AWS?
Absolutely. So we are again, we are a startup. So we have to be very focused on what we are trying to do. So we are currently supporting DigitalOcean, Rackspace, and Rackspace, the VM base, not the OpenStack fully OpenStack big. Absolutely. I mean, if somebody's interested, we'll be more than happy to work with them and try to see how we can get there. So, yeah. So.
Yeah, so you mentioned like the 6,000 customers, and then you mentioned last year, you kind of were having this problem with moving the VMs. So what was the original thing? What was the original problem that you had that kind of led you into this?
So there were 2 things, right? One was the problem that we actually had. Sorry, the question was, what was the original problem that we had and what do we have right now? So the original problem was 2-fold. One was the fact that the economies of scale wasn't there. So
I'm saying your original business problem, because it almost sounds like you guys could have pivoted right before sometime.
yeah, so basically we were passionate about bringing CI into the cloud. And we wanted to bring CI into the cloud in such a way where it's not like VM-based and you're doing a lot of heavy lifting. Like the original idea back in February of 2013 was, if GitHub could actually build a pretty UI on top of Git, why can't we build a pretty UI on top of Jenkins and be done with it? I mean, that was exactly what the reason was. And Manisha, my co-founder, is here, and that was how I convinced her that we should do this. But the problem was we started seeing economies of scale problems, we were having VM issues, all kinds of stuff. And so back in last April, we actually ended up deciding to build our own complete Jenkins fabric-like thing. And we built it in such a way that it was not server-based, it was container-based. And that's some of the Any other questions? Cool. Thank you very much, guys, and you can feel free to grab me if you have any other questions or anything. Cool. Thank you.
This one work? Yep. Thanks, Avi. Appreciate you coming down and
Oh, no worries. Thank
presenting
you.
it.
Thank you.
So we're going to have an update on a project that we talked about last time. It'll be real brief. We're going to have Vlad Kus come up, and he's going to give an update on a project that we're working on internally, Skybase. It's kind of a tool that we needed internally that ties in with Shippable as well, and Docker. Even regardless of whether we use Docker, our own images, or tarballs, or whatever, it gives us the ability really to kind of do DevOps to the cloud or to the data center. So I'll invite up Vlad Kus for that, a brief update on what we're doing and when we are going to follow up on when we're planning to open source this.
Hi. Sorry. So I guess it will be only presentation of 1 or 2 slides. And idea is that last time we talked about the Skybase and it was started at Lithium as project to automate all DevOps tasks, something like take this package, install there, take this release of this service, install into different place, and so on. But then we realized that independent from what we are deploying and where we are deploying, the major point and major pain point for a lot of DevOps situation is that we need central location for execution and registering tasks which were executed and what happened. So essentially, base functionality of Skybase is deploying the services in the deploying the services into hybrid clouds, and this includes CFN management, CFN CloudFormation templates management, managing different YAML repos and file servers which are used to install different machines, managing chef servers to promote different cookbooks from one environment to another. And essentially, Skybase is the consumer of what Shippable will produce. Let's say we have Docker or whatever immutable release of artifacts of any builds, and then Skybase picks it up and pushes it in some different place. Currently, we have a system which we are planning to release internally in the beginning of August, and this system includes command line interface which can deploy artifacts into different environments, and also it can be installed on multiple machines at the same time, so to allow for enterprise scalability. We're using different technologies for this project. Essentially, the Skybase is written in Python. It uses Tornado framework for REST API, RabbitMQ for messaging, Celery for worker processes, Couchbase as a result backend, Chef and Salt for configuration management, and Hubot for workflow controls. Just brief update on the planned timeline of different releases. Standalone workstation-based functionality and multi-server-based functionality with REST API. We are planning to release first week of August. After that, we are planning to pack it up and release into open source in August. And then we start to add functionality like workflow control with HipChat integration using Hubot. And after that, currently we're focusing on deployment into Amazon, but after that we'll start to integrate with OpenStack and Docker. Integration with external services for monitoring of running production and managing already deployed services will come in Q4 of this year. And additional scenarios and use cases for not only for first-time deployment of services, but updates and complex switching of back and forth of the running services is coming after that. As we go, as we have it ready, we will add them. So this is essentially it. So thank you. I guess the main point that in August it will be open source, and then after that we'll see how it goes, and we invite everybody to participate in this project. This is the project why we're not releasing it yet, because we have to decide on that. Most likely GPL, but I'm not sure.
Oh boy, it's raffle time. Yeah! Chromecast. I don't know why I did not enter the raffle. What's wrong with me? I don't think I was qualified. So, let's get someone up here to pull a number out of this bag. Who would like to be a volunteer? Anyone? Raise your hand. Darren. Thank you, Darren, for volunteering, even though you didn't raise your hand. Okay, don't look. You can't look inside the bag when you pull the number. Look away. Look away. Okay. Okay, here we go. Pull out a number. Call it.
915495.
Do we have a winner? Do we have? Ooh, yes! What's this? Repeat it.
915495.
Oh, yes, we have a winner. Okay.